This is one of the systems from one of the three pre-engineered product lines we have. This is our HOS line, and it's sort of a scaled down version of one of our thermal fluid systems. They are available in 6 different capacities: 40 kW, 80 kW, 120, 160, 200, and 240 kW. 3 different pump sizes, and they're all designed to 550 degrees F. This particular unit we're going to test today is our 80 kW hot oil system. The expansion tank it's an important component of the hot oil system. You'll notice that the tanks that come with this particular product line and our other pre-engineered product line, it's hooked up as a single leg tank, but the tank includes another nozzle. If you want to use it as a double leg, you can actually connect this to the piping outside of the footprint of the hot oil system. The single leg tank, there's no flow through the tank. It just provides a path for expansion. We have an air bleed coming off of our heater that we will open up during the initial startup here to help push any air that might be in the loop that's collected at the top of the heater into the tank. But if you elect to do the double leg tank, you would need to put a valve in between, and you can actually divert the flow through the tank and then back down through the system. It's a very common practice with process loops that have much larger volumes of oil. But the tank has that feature if you so choose to include it in the process. The insulation we use is a foam glass. It's a closed cell. It's non-wicking, non-absorbing, and it's designed for high temperatures. And that's what we include in our thermal fluid systems, and it's installed on the piping underneath this embossed aluminum jacketing on this particular unit. So this particular pre-engineered system, all of these this is our electric heater. They all include ASME code vessels. We have a code plate here that's a UM stamp that's included with every one of these units. Again, this is the 80 kW system. This is the thermocouple that we're sensing and controlling the oil temperature on the PID temperature indicating controller. So basically the flow is coming into the heater at the top, it's going down through the heater, and it's coming out, and it's going out through the piping to your process equipment. And we're controlling the temperature at that location there. On these units here, we also include a supply side valve and a return side valve. The return side valve is a gate type, so its primary purpose is isolation. What we include on the supply side are globe valves, so it could be used for isolation purposes, but the main feature of putting a globe valve here is it's kind of a circuit setter, so it's very good at adjusting pressures and adjusting flow. So right now we're in a full open position. We feel we've got 80 gallons per minute through this short circuit, but if you needed to, if we thought we were way out on the curve, we could actually throttle this close, bring us back on the curve a little bit, and try to position the flow more in line with the design point at 80 GPM with this particular system. The high temperature switches that we include with our hot oil systems are of a manual reset type. We try to sense the temperature of the sheath on the heating element, and if it does pick up a temperature that's elevated, it trips the alarm. So in order to acknowledge that, we have to reset the alarm. It's not a cycling type. This is our PID temperature indicating controller. The upper display will be your oil temperature. This is the temperature that we control around. It's the temperature of the oil that's being delivered out to the process. This is our set point temperature, and those can be easily changed just with the up and down arrows. We have a local e-stop, and then we also include hour meters with all of our control centers. This actually is tied into the pump, so it's kind of a pump run meter is what it's actually reading. All of our alarms are also interlocked. The high temp will drop out the heater if it trips. The low pressure will drop out the pump, which is interlocked with the electric heater, so it'll drop both of those out. The low level is actually interlocked with the pump, which is interlocked with the electric heater, so the low level switch will drop both of those out as well as an interlock. And this is a heater enable, disable, on, off. Right now, the heater's in off position. Basically what this does is when we go to on, it'll pull a set of contactors in and allow the heater to be operable. And at that point, the controller and the SCRs will take over controlling the output of the heater based on the difference between your oil supply temperature and your set point temperature.